Jai Hind everyone, I am Dublish. Welcome you all in my lecture. Today, my topic of lecture is sensor and actuator and its types. So this topic is from IUT and the subject code is for KC043 for MCA student, and lecture would be beneficial for BTech CS and IT student. So what is sensor? Sensor basically it detects a senses challenges in ambient conditions or in the state of another device or system and forward or process this information in a certain manner. In a technical term, we can say a device which detects or measures a physical property and records, indicates or otherwise responds to it. So basically, sensor performs some input function by sensing or feeling the physical changes in the characteristic of a system in response to a stimuli. For example, we can say heat is converted to electrical signal in a temperature sensor, or atmospheric pressure is converted to electrical signal in a barometer. Next term is included in a sensor is what is transducer. Transducer convert or transduce energy of one kind into another. For example, we can say in a sound system, a microphone input devices convert sound wave into electrical signal for an amplifier to amplify a process, and a loudspeaker, which is an output device, to convert this electrical signal back into sound waves. So what is the difference between sensor and actuator? Sensor, basically the word transducer is a collective term used for both sensor, which can be used to sense a wide range of different energy forms such as movement, electrical signal, radiant energy, thermal or magnetic energy, etc. And actuator, which can be used to switch voltage into current. So what are the sensor feature? Sensor feature, it is only sensitive to the measured property. Example, a temperature sensor senses the ambient temperature of a room. It is insensitive to any other property likely to be encountered in its application. Example, we can say a temperature sensor does not bother about light or pressure while sensing the temperature. So it does not influence the measured property, like measuring the temperature does not reduce or increase the temperature. So next topic is what is sensor resolution. So the resolution of a sensor is the smallest challenge it can detect in the quantity that is measuring. So the resolution of a sensor with a digital output is usually the smallest resolution in the digital output it is capable of processing. And the more is the resolution of sensor, the more actuator is its precision. So a sensor accuracy does not depend upon its resolution. So these are the sensor classes. Based on we can divide sensor classes based on two types. First one is based on output and second one is based on data type. Based on output, we can divide sensor classes in two parts. First one is analog and digital, and based on data type, we can divide sensor class in two parts. First one is scalar and second one is vector multimedia. So now, what are analog sensor? Analog sensor produce a continuous output signal or voltage which is generally proportional to the quantity being measured. So, physical quantities such as temperature, speed, pressure, displacement, strain, etc. are all among quantities as they tend to be continuous in nature. For example, the temperature of a liquid can be measured using a thermometer or thermocouple, example in geysers, which continuously responds to a temperature changes as the liquid is heated up or cooled down. Digital sensor produce digital sensor produce discrete digital output signal or voltage that are a digital representation of the quantity being measured. So digital sensor produce a binary output signal in the form of logic 1 or 0, that means on or off. So a digital signal may produce discrete non-continuous values which may be output as a signal bit, serial transmission, or by combining the bits to produce a single byte output parallel transmission. Scalar signal produce output signal or voltage which is generally proportional to the magnitude of the quantity being measured, and the physical quantities such as temperature, color, pressure, strain, etc. are all scalar quantities as only their magnitude is sufficient to convey an information. For example, the temperature of a room can be measured using a thermometer or thermocouple which responds to temperature changes irrespective of the orientation of the sensor or its direction. Now, next one is vector sensor. Vector sensor basically produce output signal or voltage which is generally proportional to the magnitude, direction as well as the orientation of the quantity being measured. So basically physical quantities such as sound, image, velocity, acceleration, orientation, etc. all are vector quantities as only their magnitude is not sufficient to convey the complete information. For example, the acceleration of a body can be measured using an accelerometer which gives the component of acceleration of the body. with respect to the XYZ coordination axis. So, sensor type was basically depend on light, temperature, force, position, speed, sound, chemical. So these are the example which we have covered. And next one is what are the sensorial deviation. So since the range of the output signal is always limited, the output signal will eventually reach a minimum or maximum when the measured property exceed the limit. So the full scale range of a sensor defines the maximum and minimum value of the measured property. So the sensitivity of a sensor under real condition may differ from the values specified. So this is called a sensitivity error. If the output signal differs from the correct value by a constant, the sensor has an offset error or bias. So non-linearity, basically non-linearity is a deviation of a sensor transfer function from a straight line to transfer function. So this is defined by the amount the output differs from ideal TF behavior over the full range of the sensor, which is denoted as a percentage of the full range. So most sensors have linear behavior. If the output signal slowly changes independent of the measured property, this is defined as the drift. So long-term drift over month of the year is caused by the physical changes in the sensor. So basically noise is a random deviation of a signal that varies in a time. Next thing arises in this is hysteresis error. A hysteresis error causes the sensor output value to vary depending on the sensor previous input value. So if a sensor output is different depending on whether a specific input value was reached by increasing or decreasing the input, then the sensor has a hysteresis error. So the represent reading depend on the past input value. Typically in analog sensor, magnetic sensor heating of metal strips. Other kind of error occur like if the sensor has a digital output, the output is essentially an approximation of the measured property. So this error is also called quantization error. If the signal is monitored digitally, the sampling frequency can cause a dynamic error of if the input variable or added noise changes periodically at a frequency proportional to the multiple of the sampling rate. Arising errors may occur so that the sensor may to some extent be sensitive to properties other than the property being measured. For example, most sensors are influenced by the temperature of their environment. Next term arises, what is actuator? So basically an actuator is a component of a machine or a system that moves or controls the mechanism of a system. An actuator is the mechanism by which a control system acts upon an environment. So an actuator requires a control signal and a source of energy. Upon receiving a control signal is received, the actuator responds by converting the energy into mechanical motion. So the control system can be simple, a fixed mechanical or electronic system, or we can say software based, a printer driver, robot control system, or human or any other kind of input. So we have current electrical current voltage, it will convert in pressure like pneumatic error, then convert into mechanical drive by crankshaft, and control signals convert into an actuator. So we have this kind of actuator type. First one is hydrochloric, pneumatic, electrical, thermal and magnetic, and last one is mechanical. So we will describe these types of actuator in description form. So what are the hydrochloric actuator? So hydrochloric actuator consists of a cylinder or fluid motor that uses hydrochloric power to facilitate mechanical operation. So the mechanical motion is converted to linear, rotatory or oscillatory motion. So since liquids are nearly impossible to compress, a hydraulic actuator exerts considerably force. So the actuator limited acceleration restricts its uses. These are the figures of hydrochloric actuator. Next one is pneumatic actuator. A pneumatic actuator converts energy formed by the vacuum or compressed air at high pressure into either linear or rotatory motion. So pneumatic rack and pinion actuator are used for value control of the water pipes. So the pneumatic energy quickly responds to starting and stopping signal. The power source does not need to be stored in reserve for the operation. So the pneumatic actuator enable large force to be produced from the relatively small pressure changes like Pneumatic brakes are very responsible to small changes in pressure applied by the driver. So it is responsible for converting pressure into force. So functional components of IoT, basically component for interaction and communication with other IoT devices, component for processing and analysis of operation, component for internet interaction, and component for handling web service of application, component to integrate application service, user interface to access IoT. We can convert the categories of IoT. So we have some categories of IoT. First one is like industrial IoT, consumer IoT. So what is the term industrial IoT? We can say in short way IIoT. So the IoT device connect to an IP network and a global internet. So the communication between the nodes done using regular as well as industry specific technology. This is come under the category of industrial IoT. And the consumer IoT device, IoT device communicate within the locally networked devices. So local communication is done mainly via Bluetooth, Zigbee or Wi-Fi. So consumer IoT generally limited to a local communication by a gateway. So this is the IoT gateway architecture, in which we have local network, global network, and software like switching, routing, protocol conversion, firewall, and security processor. So these come under the category of wired and wireless connection. And these are all the IoT and its associated technology like big data, cloud, smart grid, M2M, telemedicine, CPS, 3G, 4G, 5Gs. Now we will cover the IoT challenges we face in the term of security, scalability, energy efficiency, and what are the bandwidth management, modeling and analysis, interfacing, interoperability. These are called kind of IoT challenges. So now we will cover what are the hardware for IoT. So the hardware utilized in IoT system include device for a remote dashboard, device for control server. Servers are routing or bridge devices, or we can say sensor. So these devices managed by key tasks and functions such as system activation, action specification, security communication, and detection to support a specific goal and some actions. So the IoT sensor, the most important hardware in IoT, we can say must be its sensor. So these devices consist of energy modules, power management modules, RF modules and sensing modules. So the RF modules manage communication through the signal processing, Wi-Fi, Zigbee, Bluetooth, radio, transceiver, duplexer and VAW. And basically actuator type of transducer that you will encounter in many IoT systems is an actuator. So in simple terms, an actuator operates in the reverse direction of a sensor. It takes an electrical input and turns it into physical action. For instance, an electrical motor, hydraulic system and a pneumatic system are all different type of actuator. So the controller is basically in typical IoT system, a sensor may collect information and route it to a control center. So their previously defined logic dictates the decision. As a result, a corresponding command control and actuator is response to that sense input. So the sensor and actuator in IoT work together from opposite ends. So later we will discuss where the control center resides in the greater IoT system. To its sensing, the module managed to sense through assorted active and passive measurement devices. So the current smart wearable device include we have devices for head, arm, neck, torso, feet. So for head we have some kind of IT devices like helmet, glasses, and for neck we have jewelry, collars, arm watches, wristband rings, torso clothing and backpacks, and for feet we have socks and shoes. So the standard device, the desktop, tablet and cell phone remain integral part of IoT as command center and remotes. So the desktop provides the user with the highest level of control over the system and its setting. The tablet provides access to the key feature of the system in a way resembling the desktop and also act as a remote. So that cell phone allows some essential setting modification, also provide remote functionality. And other key connected devices include standard network device like router and its switches. So IoT primarily exploits standard protocols and networking technology. However, the major enabling technology and protocol of IoT are RFID, NFC, low energy band Bluetooth, low energy wireless, low energy radio protocols, and Wi-Fi direct. So these technologies support the specific networking functionality needed in the IoT system in a contrast to a standard uniform network of a communication system. So what are the NFC and RFID technology? So RFID, the full form of RFID is radio frequency identification, and NFC is near held communication, provide simple, low energy and versatile option for identity and access tokens to connection, bootstrapping and payment system. So RFID technology employs two-way radio transmitter receivers to identify and track associated with object. So NFC consists of communication protocol for electronic device, typically a mobile device and a standard device. So again, this divided in many parts. First one is low energy band Bluetooth. So low energy Bluetooth, basically it's a technology supported by the low power, long use need for the IoT function while exploiting a standard technology with native support across system. Next one is low energy wireless. So this technology replaces the most power hungry aspect of an IoT system. So through sensor and those sensor and other element can power down over long period. So communication link that is wireless must remain in listening mode. So low energy wireless not only reduce consumption but also extend the life of the device through less use. Next one is radio protocol. So the Zigbee, Z-Wave and Thread or radio protocols for creating low rate private area networks. So these technology are low power but offer high throughput unlike many similar options. So this increases the power of a small local device network without the typical cost. Or the LTE or LTE Advanced, we can say, delivers an important upgrade to LTE technology by increasing not only its coverage but also reducing its latency and raising its throughput. It gives low tremendous power through expanding its range, with its more significant application being a vehicle, UAV and so the Wi-Fi Direct eliminates the need for an access point. It allows peer-to-peer connection with the speed of Wi-Fi, but with lower latency. Wi-Fi Direct eliminates an element of a network that often boxes down and it does not compromise on speed or throughput. So next topic we will cover in today's lectures, what are wireless sensor network. This topic we will cover in our next lecture. Thank you.